Namaste students, in this video we are going to see a chapter probability. What is the meaning of probability? There are some events about which we are not sure or certain, like the following. Will rains be good this year? Will I get good marks in my next maths test? Will I be able to get home on time to attend the party? Who will be the next World Cup cricket champions? Also, if we toss a coin, we cannot say for certain whether the head will show up or the tail will show up. The outcomes of such actions as tossing a coin, throwing up a die, or drawing a card from a well shuffled pack of cards all depends on chance. Chance, an important part in life. For example, sweets are determined by checking a sample, like testing a single piece. Gamblers always depend on chance. In fact, the theory of probability was first applied to gambling. So, the simple definition of probability is the chance that something will occur. It has percentage of both success and failure. It is qualified as a numbers between 0 and 1. Before enter into the probability problems, I just want you to know some basic terms and concepts. The first one is experiment, a process which results in some well-defined outcome is known as an experiment. For example, when a coin is tossed, we shall be getting either a head or a tail. That is, its outcome is a head or a tail that we know already, that is well defined. Like when a die is thrown, the possible outcomes are 1, 2, 3, 4, 5 and 6, which are also well defined. Clear? This is experiment. Definition of experiment. Next, outcome. A possible result of a random experiment is called an outcome. A possible result. What are all possible results we will get for that experiment is called an outcome. But in this, what is the meaning of random experiment? Random experiment means all the outcomes of the experiment are known in advance, but any specific outcome of the experiment is not known in advance. For example, tossing a coin is a random experiment because there are only two possible outcomes, head or tail, and these outcomes are known well in advance, but the specific outcome of the experiment, that is whether a head or a tail, is not known in advance. Throwing a die is a random experiment because we know in advance that there are only 6 possible outcomes of the experiment, that is 1, 2, 3, 4, 5 and 6. But it is not possible to know which of these 6 numbers will finally be the result. Next, sample space. The set of all possible outcomes of an experiment is called sample space. In general, denoted by letter S. So, sample space is nothing but set of all possible outcomes. Let's see some example for sample space. When we toss a coin once, it may come up in either of two ways, head or tail. So, there are two possible outcomes of this random experiment. Thus, the sample space of this random experiment is H, T. Next example, when two coins are tossed together, then the sample space is head on the first coin and head on the second coin. Next one, head on the first coin and tail on the second coin. Third one, tail on the first coin and head on the second coin. Then fourth one, tail on the first coin and tail on the second coin. Thus, the corresponding sample space, that S is equal to H, 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 T, T, H, T, T. Like this, when three coins are tossed together, the sample space is H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, T, T, T. These are the sample space when we toss three coins. Example, when we roll a dice once, it may land with any of its 6 faces pointing upward. Thus, the outcome of this experiment is getting any of the 6 number 1, 2, 3, 4, 5 and 6. Hence, the sample space for the experiment is S is equal to 1, 2, 3, 4, 5, 6. And N of S, the number of sample space, is equal to 6. Next, when we throw two dice together, we will get the sample space like this. That S is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 and 2, 1, 2, 2, 2, 3, 2, 4 like this. You have to write till 6, 6. These are possible outcomes when we throw two dice. Therefore, N of S is equal to 36. Next example is, in a deck of cards there are 52 of them, out of which there are 26 red cards and 26 black cards. So totally N of S is equal to 52 cards. So in a pack 52 cards and 26 red cards and 26 black cards. Below 26 red cards we have two categories. First one is 13 hearts and then 13 diamonds. In the black card, under the black card we have 13 spades and 13 clubs. So totally 52 cards. Next, face cards. Face cards are J, Q, K. In each set we have 3 cards. Totally how many sets we have? 4 sets. So 4 into 3 is equal to 12. So totally in a pack we have 12 face cards. These are the examples for sample space. Next important term is event. Any possible outcome of a random experiment is called an event. Any possible outcome of a random experiment is called an event. E is equal to event and P is equal to probability. Then P of E is equal to probability of an event E. Probability is classified into two categories. First one is experiment or empirical probability and second one theoretical or classical probability. First one, experiment or empirical probability. A probability is based on the outcome of an actual experiment and adequate recording. And next one is theoretical or classical probability. A probability is based on the assumption about the occurrence of an event E rather than the outcome of an actual experiment. See the below figure. First one is impossible, second one is unlikely, even chance, likely and certain. First one is impossible. Can you tell me one example for impossible event? That planet Mercury is a luminous body. Then for unlikely, a good example is 1 in 6 chance. In a die, 1, we have to get 1 in 6 chance. That is unlikely. And even chance. Coin comes up heads. And next one is likely. That is in 3/4 ratio. I tell you one good example that no one will be absent today. Next one, certain. The sun will rise in the east. The sun always rise in the east only. That is certain. So first one is impossible. Second one is unlikely. Next, even chance and likely and certain. So probability is a way of measuring the chance of an event occurring. We calculate the probability of P of E of the occurrence of an event E. P of E is equal to number of favorable outcomes divided by total number of possible outcomes, where outcome is a result of an experiment. Outcome is a result of an experiment that you have to write in the denominator, and favorable outcome is an outcome that matches the event. The favorable outcome you have to write in the numerator. Therefore, the formula is to find the probability number of favorable outcome divided by total number of possible outcome. Trick to do probability problems, that what are all steps we have to follow to get the answer. So first we have to write sample space, that all possible outcomes we have to write in the sample space, and n of s, number of sample space, and then a, that given question what they ask us to find, that you have to take let, and then a, that favorable outcome, what are all favorable outcome, and then n of a, that is number of favorable outcome. Then the answer P of a, that is probability of a, is equal to n of a divided by n of s. That is the answer. So first we have to find possible outcomes, that is sample space. Yes, n of s, let a, n of a, and the answer P of a is equal to n of a divided by n of s. Follow these steps for all the problems to get the answer easily. Notes. First one, the probabilities of all possible outcomes of an event add up to 1. If you add all the possible outcomes of an event, means definitely you will get 1. Second one, probability of event not happening is equal to 1 minus probability of event happening, that is P of E bar is equal to 1 minus P of E. Next, third one, probability of a sure event certain is 1. Fourth one, probability of an impossible event is 0. So the probability answer always lies between 0 and 1. That is 0 less than or equal to P of E less than or equal to 1. Are you all clear, children? I hope all of you understood the introduction of probability very well. Thank you.